Every day, you sit on a device that uses no electricity, has no motor, no computer chip, no moving electronics, and yet it moves 2 gallons of water and everything in it to a place you'll never see in under 4 seconds, using nothing but gravity and a 250-year-old physics trick. Your toilet is one of the most ingeniously designed machines in your house, and the secret behind it is a mechanism so elegant that even NASA uses a version of it in spacecraft. It's called a siphon. Let's start with what's actually inside a toilet, because most people have never looked. There are two main parts, the tank and the bowl. The tank is the box behind you. It's a water reservoir, about 1.6 gallons in a modern toilet. Inside the tank, you've got 3 key components: the flapper, the float, and the fill valve. The bowl is the part you're more familiar with, but hidden inside the porcelain, and this is the part almost nobody knows about, is a curved channel called the trapway. It's an S-shaped tube that snakes through the porcelain body of the toilet. That S-curve is everything. It's the reason your toilet works, the reason your bathroom doesn't smell like a sewer, and the reason you don't need electricity to flush. Here's a demonstration you can try right now. Take a cup of water and pour it slowly into your toilet bowl. Nothing happens. The water level doesn't even rise. The extra water just trickles over the bend in the trapway and drains away. Now take a bucket, about 2 gallons, and pour it all in at once. The toilet will flush completely, even without touching the handle. What just happened? You triggered a siphon. The S-shaped trapway has a high point, the top of the bend. Under normal conditions, the water in the bowl sits just below that high point. When you pour water in slowly, it just trickles over the bend. No big deal. But when you dump water in fast enough, you fill the entire trapway with a continuous column of water. And once that column extends past the high point and starts flowing down the other side, down the longer leg of the S, gravity takes over. The weight of the water falling down the long side creates a vacuum that pulls more water up from the bowl side. This creates a self-sustaining cycle. Water continuously gets sucked up and over the bend. The bowl empties rapidly, pulling everything with it. The siphon keeps running until the water level in the bowl drops so low that air enters the trapway. That air breaks the continuous water column, the vacuum collapses, and the siphon stops. That gurgling sound at the end of a flush? That's air breaking into the trapway. So if a bucket of water can flush a toilet on its own, what does the handle do? Simple. It dumps the tank water into the bowl all at once. When you press the handle, a chain lifts a rubber disc called the flapper off the drain hole at the bottom of the tank. The entire contents of the tank, about 1.6 gallons, rush down into the bowl through 2 paths. Path 1. Small holes under the rim called rim jets. These spray water around the inside of the bowl in a swirling pattern, cleaning the porcelain surface. Path 2. A larger opening at the bottom of the bowl called the siphon jet. This hole aims directly into the trapway entrance, shoving water in with enough force to prime the siphon immediately. The whole flush takes about 3 seconds. The flapper falls back into place once the tank is empty, sealing the drain. The fill valve opens and slowly refills the tank over the next 30 seconds or so, controlled by the float. When the water reaches the right level, the float shuts off the valve. No electronics, no computer. Just gravity, water pressure, and clever geometry. There's one more brilliant detail about that S-shaped trapway. After every flush, a small amount of water settles back into the bottom of the S-curve, creating a water seal. This water seal is the only thing between your bathroom and the sewer system below. Without it, methane and hydrogen sulfide gases from decomposing waste would rise directly into your home. The curve in the pipe traps water that acts as a permanent gas barrier. This invention, the S-trap, was patented by Scottish watchmaker Alexander Cumming in 1775. It was such a good idea that every toilet, sink, and drain in your house still uses the same basic principle today, 250 years later. Today's toilets are engineering marvels of efficiency. Older toilets used 3.5 to 7 gallons per flush. Modern low-flow toilets use just 1.28 gallons, and they flush just as effectively. How? Engineers redesigned the trapway to be narrower and more precisely curved, so the siphon forms more easily with less water. They optimized the angles of the rim jets for faster bowl coverage. They applied ultra-smooth glazes to the bowl interior to reduce friction. Every fraction of a second and fraction of a gallon has been fine-tuned. And then there are pressure-assisted toilets, which use compressed air to blast water into the bowl at much higher velocity. These are the ones you hear in airports and offices, the loud ones that sound like a small jet engine. They use as little as 1.0 gallons per flush. Dual flush toilets give you a choice: a half flush for liquids, a full flush for solids. Same siphon principle, just with the option to use less water when you don't need the full force. So the next time you flush, take a moment to appreciate the engineering masterpiece beneath you. No electricity, no motors, no chips. Just a 250-year-old physics trick, a rubber disc, and the most reliable machine in your house. Next up, we're going inside your own body to answer a question you've probably wondered your entire life. What actually happens when you crack your knuckles? And no, it doesn't cause arthritis. Subscribe, and I'll prove it.